In this video, I want to have a look at quadratic identities. So if two quadratic expressions are equivalent, that means that the corresponding coefficients must be equivalent. So for example, if we had a1x squared plus b1x plus c1, where a1, b1 and c1 are just numbers, they're just constants, and that's equal to a2x squared plus b2x plus c2, then those coefficients have to be equal. So the a1 has to be equal to the b1 because they're both the coefficients of x squared. The b1 has to be equal to the b2 because they're both the coefficients of x. And the c1 and c2 have to be equal because they're both the constant terms. So let's have a look at what that looks like with an example. So our first example asks us to find the values of a, b, and c so that x squared plus 4x minus 3 is equivalent to or equal to exactly the identity of a x plus 1 squared plus b x plus 1 plus c. Now there's two different ways we can approach these questions. So we're going to go through both methods for this problem and you can have a look and see which one that you think is going to be easier and makes more sense to you. So our first way of doing it, it's called method 1, is we can take this expression, we can expand everything out and then collect all our x squareds together, all our x's and our constants, and then equate the coefficients. So we've got a x plus 1 squared plus bx plus 1 plus c is equal to, and then we want to expand this out. So the a I'm just going to leave there for a moment while I expand this bracket out. So x plus 1 squared would expand to give us x squared plus 2x plus 1. Then if we expand this one out, we'd have bx plus b. And we've still got that c term on the end as well. Then if we expand this first bracket out, we'd have ax squared plus 2ax plus a plus bx plus b plus c. Right, so now we want to collect our like terms. So this is our only x squared term, so that'll just stay as ax squared. Then if we look for our x terms, we've got 2ax and we've got bx. So if we collect those and factorize at the same time, we're going to have 2a plus bx. So we've pulled out the x as the common factor and we're left with the 2a plus b. And then we've got our constant terms there as well. So we've got our a, our b, and our c. So they'll all go together at the end. So plus a plus b plus c. And I'm just going to put them in brackets. They don't need brackets, but I'm going to do it so that we can tell that that whole thing there is our constant term. So now we can look back at this equation at the top and we can equate coefficients. So the coefficient of x squared is just 1, which means that our coefficient of x squared, our a, has to be equal to 1. So a equals 1. That's our first letter found. Then we can equate the coefficients of x. So we've got 2a plus b, and that has to equal 4. So we're going to have 2a plus b is equal to 4. But we know that a is 1, so 2 times 1 is just 2, plus b equals 4, which means that b is equal to 2. Then we can do this last constant term, so we're going to have a plus b plus c is equal to that minus 3. So a plus b plus c equals minus 3, but we know that a is 1 and b is 2. So that means we've got 3 plus c equals minus 3, which means that c equals minus 6. So our solution is a equals 1, b equals 2, c equals minus 6. So that's the first way we can solve it. So the second method of solving it, the first part is that we know just by looking, so without doing any expanding, that the only x squared term we're going to get is from this section, this term of that expression. So that means that the coefficient of x squared is going to be a. So that means without expanding it, we can equate coefficients already. So we can just say, if we write our reasoning, if we write equating coefficients of x squared, then a is equal to 1. So we can do that straight off. The next step is to be a little bit clever about picking a value for x that we're going to substitute in to make our expressions a little bit simpler so that we can equate a few more things. So if we were to pick x equals minus 1, that would make this whole bracket and this bracket equal to 0, which would just sort of cancel out both of those terms because they reduce down to 0. So if we let x equal -1, we're going to substitute that into this whole expression. So on this side, we're going to have -1 squared plus 4 times -1 minus 3. And that's going to be equal to, well, -1 plus 1 is 0, so that whole term's gone. And -1 plus 1 is 0, so that whole term's gone as well. So all we have left on this right-hand side of the equation is c. So that's going to give us 1 minus 4 minus 3 is equal to c, which would give us -6 is equal to c. So if we just write that the other way, c is equal to -6. So now we've got our a and our c, we need to find b. So we need to pick another value to put in for x that'll make things a bit simpler. One that's usually really nice to pick is just 0. So let's go let x equal 0. So on this left-hand side of the equation, that's going to give us 0 here and 0 for this one. So we're just going to be left with -3 is equal to, now when we do this, we're going to have a outside of 1 squared plus b outside of 1 plus c. So that's just going to give us -3 equals a plus b plus c. Now we already know that a is 1 and that c is -6, so we can put those in. So we can have -3 equals a, sorry, not a, 1 plus b -6. So -3 equals b -5, which means that b is equal to 2. So that's our three answers again. A equals 1, B equals 2, C equals -6. It's just a different method of getting to those answers. So I want to have just another look at that second method of doing things with a different example. So find the values of A, B and C for which 2x squared minus 3x plus 1 is equal to A outside of x plus 2 squared plus B x plus 2 plus C. So first thing we're going to do is equate coefficients. Of x squared. Now we know again that our x squared term is going to come from this expansion, so that's going to give us that a is equal to the coefficient of x squared here, which is 2. So that's our first value. Then we're going to pick numbers that will make these brackets go to 0. So we're going to let x equal -2. So on this side then, we're going to have 2 times -2 squared minus 3 times -2 plus 1. And that's going to equal, now because we've picked that to make these brackets go to 0, on this right-hand side, we're just going to be left with C. So we're going to have 2 times 4 plus 6 plus 1 equals C. So we've got 8 plus 7 would give us 15. So C is equal to 15. So that's our second value that we needed. And then we need to pick another value for x. So again, x equals 0 is usually a pretty nice one to pick because it makes this right-hand side really easy. So that's going to give 0 minus 0 plus 1. So we're just going to have 1 is equal to, and that's going to give us a outside of 2 squared plus b outside of 2 plus c. So that's going to give us 1 equals 4a plus 2b plus c. Now we know the values of a and c, so we can substitute those in. So we're going to have 1 equals 4 times 2 plus 2b plus 15. And simplifying that, 1 equals 8 plus 2b plus 15. 8 and 15 gives us 23. And I've run out of room, so I'm just going to do it up here. So if we subtract 23 from both sides, then we'd have -22 equals 2b, and then divide both sides by 2, and we're going to end up with b equals -11. So our three values are a equals 2, c equals 15, and b equals -11. So that's two methods for solving problems involving quadratic identities.